Deployment strategies for China's Xuntian Space Telescope in 2026, 5 essential phases and $150 million budget allocation for advanced imaging technology. China is on the brink of a transformative leap in space exploration with the anticipated launch of its next-generation space telescope, the Xuntian, officially known as the China Space Station Telescope (CSST). Slated for deployment in late 2026, this ambitious project aims to position itself alongside renowned observatories such as the Hubble Space Telescope and the James Webb Space Telescope (JWST). With a dedicated budget of approximately $150 million allocated for advanced imaging technology, the Xuntian is poised to unlock new frontiers in our understanding of dark matter, dark energy, and galaxy evolution. Key features and capabilities. The Xuntian will be equipped with a primary mirror measuring 2 meters, about 6.6 feet in diameter, while slightly smaller than Hubble's mirror. The Xuntian compensates for this with groundbreaking optics that afford it an impressive field of view, 300 times larger than that of Hubble. This expansive capability enables the telescope to conduct extensive surveys across 17,500 square degrees of the sky over its projected 10-year operational lifespan. The telescope is designed to observe a wide spectrum of light from near ultraviolet to near infrared. Its primary objectives include measuring weak gravitational lensing. By studying the bending of light from distant galaxies as it passes through regions of high matter density, the Xuntian aims to map the distribution of dark matter. This technique will provide critical insights into the cosmic structure and the influence of dark matter on galaxy formation. Studying cosmic voids and clusters, the telescope will delve into the properties and distribution of cosmic voids and clusters, contributing to our understanding of dark energy and the universe's expansion dynamics. Advanced imaging technology. The allocation of $150 million will facilitate the development and integration of cutting-edge imaging technology, enhancing the telescope's observational capabilities and data collection methods. Maintenance and upgradability. A distinctive feature of the Xuntian is its operational strategy, which includes sharing an orbit with the Tiangong space station. This proximity allows for regular maintenance and upgrades by astronauts, an advantage that is not available to telescopes like the JWST, which is stationed approximately 1.5 million kilometers from Earth and cannot be serviced. The ability to perform repairs and upgrades in orbit enhances the longevity and adaptability of the Xuntian, ensuring it remains at the forefront of astronomical research. Timeline of events. 5 essential phases. Phase 1: Development and Announcement. The journey of the Xuntian telescope began several years ago, with initial plans and capabilities being publicly discussed. The telescope's potential to redefine modern astronomy has generated significant interest, leading to various announcements and updates as the launch date approaches. Phase 2: Final Assembly. As of late 2025, the telescope is expected to undergo final assembly and integration. This stage involves the meticulous construction of the telescope's components, ensuring that all systems are functioning optimally and are ready for deployment. Phase 3: Launch Preparations. With a target launch date set for December 21, 2026, preparations will intensify in the months leading up to the launch. This phase will include testing and validation of the telescope's systems, as well as coordinating logistics for the launch vehicle and mission support teams. Phase 4: Launch. The Xuntian is scheduled to lift off in late 2026, coinciding with the launch of NASA's Nancy Grace Roman Space Telescope in 2027. This timing creates a competitive landscape in space observation, with both telescopes set to contribute valuable data to the astronomical community. Phase 5: Operational Period. Once in orbit, the Xuntian will embark on a decade-long research mission. During this time, it will conduct extensive surveys, collect data, and analyze findings related to dark matter, dark energy, and galaxy evolution. The operational period will be marked by ongoing assessments and potential upgrades to enhance its scientific output. Common themes across sources.
Reports on the Xuntian telescope highlight several common themes.
Expanded field of view. The telescope's 300-fold increase in field of view compared to Hubble is frequently emphasized as a groundbreaking feature. Focus on dark matter and energy. Its role in studying dark matter and energy emerges as a central theme, underscoring the telescope's significance in advancing our understanding of the universe. In orbit maintenance, the strategic advantage of being able to perform maintenance in orbit is consistently noted as a key differentiator from other space telescopes. Differences between sources. While the core message remains consistent across various reports, differences arise in the emphasis placed on specific aspects of the Xuntian. Source 1 focuses on the groundbreaking nature of the telescope and its comparative advantages over JWST. Source 2 delves deeper into the scientific objectives, particularly the mapping of dark matter and dark energy. Source 3 highlights the collaborative potential among different telescopes and the implications for future astronomical research. Conclusion. The Xuntian Space Telescope is set to mark a significant milestone in China's space exploration efforts. With its advanced technological capabilities and strategic operational framework, it is designed not only to rival existing observatories but also to complement them in the quest for cosmic knowledge. As it prepares for launch, the Xuntian holds the promise of reshaping our understanding of the universe and establishing China as a key player in the field of modern astrophysics. The Xuntian Space Telescope, also known as the China Space Station Telescope CSST, is poised to significantly impact our understanding of the universe when it launches in late 2026. With its advanced capabilities and strategic operational framework, it presents several counterintuitive aspects worth noting. 1. Its size does not equate to capability. While the Xuntian's primary mirror measures 2 meters in diameter, making it slightly smaller than the Hubble Space Telescope, its design offers a remarkable field of view that is 300 times larger than Hubble's. This raises an interesting point. The effectiveness of a telescope is not solely determined by the size of its mirror. Instead, the advanced optics and the ability to cover extensive areas of the sky in a single observation are what will allow Xuntian to make groundbreaking discoveries. This counterintuitive notion challenges the common belief that larger mirrors always result in superior observational capability. 2. Maintenance versus longevity. A significant advantage of the Xuntian is its ability to undergo maintenance and upgrades while in orbit, a feature that is not available for most modern space telescopes, including the James Webb Space Telescope JWST, which operates far from Earth and cannot be serviced. This presents a paradox in the field of space observatories. While many assume that remote locations are ideal for telescopes due to minimal interference from Earth, the reality is that a telescope's operational life may be extended through regular maintenance. This design choice could lead to the Xuntian being operational for decades, whereas other large telescopes may be limited by technology that cannot evolve or be repaired. 3. Collaboration versus competition. There is a prevailing assumption that competition in space exploration leads to a race where nations strive to outdo each other without cooperation. However, the development of the Xuntian may foster a unique collaborative environment. It will operate alongside other significant telescopes such as NASA's Nancy Grace Roman Space Telescope and the European Space Agency's Euclid, by complementing each other's findings. These telescopes could work together to enhance our overall understanding of astrophysics. The expectation is that rather than merely competing, they will share data and insights, which is a counterintuitive outcome in the context of national interests often driving space exploration. 4. Dark matter and dark energy insights. The Xuntian is designed not only to explore dark matter and dark energy but to measure them with unprecedented precision. The idea that a single telescope could provide definitive insights into these enigmatic phenomena is counterintuitive given the complexity and scale of the cosmos. Traditional thinking suggests that multiple instruments are required to gather sufficient data for such intricate studies. However, Xuntian's advanced capabilities may allow it to achieve significant breakthroughs on its own. 5. Budget allocation relative to ambitions. While the $150 million budget allocation for the advanced imaging technology of the Xuntian may seem substantial, it is relatively modest when considering the scale of the project and the potential return on investment in scientific knowledge. This raises the counterintuitive question of whether high-quality scientific output can be achieved with lower funding compared to previous projects that have received significantly higher budgets. The efficiency of the Chinese space program in this case suggests that innovative approaches to funding and resource management are achievable, which challenges the assumption that more funding always equals better outcomes. 6. Timing in a competitive landscape. The Xuntian's launch is strategically timed to coincide with the expected launch of NASA's Nancy Grace Roman Space Telescope in 2027. This juxtaposition creates a competitive landscape, but it also opens the door for simultaneous advancements in space observation techniques. The idea that two major telescopes could enhance each other's missions rather than detract from them is counterintuitive. One might expect competition to lead to exclusive discoveries, but they could instead lead to a richer tapestry of astronomical understanding. 7. The role of the Tiangong space station. The decision to have the Xuntian share an orbit with the Tiangong space station may seem like a logistical challenge at first glance. However, this arrangement provides a unique opportunity for regular servicing and upgrades, which is not feasible for telescopes like the JWST. Hence, the ability to have a telescope in a relatively low orbit opens a new paradigm for space missions, suggesting that proximity to a service hub can be more beneficial than isolation in terms of operational success. Conclusion. The Xuntian Space Telescope embodies several counterintuitive dynamics in the realm of modern astronomy and space exploration. From the implications of size and maintenance to the potential for collaboration in a competitive landscape, the telescope's development and operational strategy challenge numerous assumptions held by the scientific community. As it prepares to launch, its unique design and capabilities may redefine our approach to studying the cosmos and solidify China's role as a key player in the field of astrophysics. The deployment of China's Xuntian Space Telescope, also known as the China Space Station Telescope or CSST, in 2026 represents a significant leap in astronomical research capabilities. While many aspects of this ambitious project are highlighted in various reports, several important details are often overlooked, which could have profound implications for the future of astrophysics and international collaboration in space science. 1. In-orbit maintenance and upgradability. One of the most significant advantages of the Xuntian Space Telescope is its operational strategy that permits in-orbit maintenance and upgrades. This feature is often overshadowed by discussions about its technical capabilities and scientific goals. The ability to dock with the Tiangong space station means that astronauts can service the telescope, replacing components and upgrading technology as advancements occur. Significance: this contrasts sharply with the James Webb Space Telescope JWST, which is stationed 1.5 million kilometers from Earth and cannot be serviced. The potential for Xuntian to remain functional and relevant for decades, adapting to new technologies and scientific needs, enhances its value as a long-term research tool. This could lead to continuous improvements in imaging technology and observational capabilities, making it a more versatile asset in the field of cosmology. 2. Wide field of view and survey capabilities. The Xuntian's design includes a primary mirror of 2 meters in diameter, which, while smaller than that of Hubble, offers a field of view that is 300 times larger. This capability enables extensive sky surveys covering approximately 17,500 square degrees over its decade-long mission. Significance: the broader field of view allows for a more comprehensive study of cosmic phenomena and could lead to discoveries that single-target telescopes may miss. The extensive surveys will enable astronomers to collect large datasets that can help refine models of galaxy formation, dark matter distribution, and the nature of dark energy. This capability is crucial for addressing some of the most pressing questions in modern astrophysics. 3. Focus on dark matter and dark energy. while the goal of studying dark matter and dark energy is often mentioned. The specific methodologies that the Xuntian will employ are sometimes overlooked. The telescope will utilize weak gravitational lensing techniques to map dark matter and assist in understanding the universe's expansion through the study of cosmic voids and galaxy clusters. Significance: these studies are pivotal for validating or challenging existing theories of gravity and cosmology. The insights gained from Xuntian's observations could lead to new models or refine current understandings, potentially reshaping our comprehension of fundamental physics. The precision with which Xuntian aims to measure properties of dark energy is particularly noteworthy, as even slight discrepancies could have far-reaching implications for cosmological theories. 4. Strategic geopolitical context. The development of the Xuntian is also significant within the geopolitical context of space exploration. Its launch is timed closely with NASA's Nancy Grace Roman Space Telescope, which could foster a competitive atmosphere in precision astronomy between the US and China. Significance: this competition may drive innovation and advancements in technology, but it also raises concerns about collaboration and data sharing in the global scientific community. The Wolf Amendment, which prohibits NASA from collaborating with China, limits opportunities for joint scientific endeavors and could lead to parallel research tracks that may miss out on the benefits of shared knowledge. The geopolitical implications of Xuntian's deployment could affect international scientific cooperation for years to come. 5. Potential for collaborative synergy. While the reports highlight the Xuntian's capabilities and missions, the potential for collaborative synergy with existing and upcoming telescopes is often not fully explored. The Xuntian could complement missions from other observatories such as the Euclid Space Telescope and JWST. Significance: by providing data that can be integrated with findings from other telescopes, Xuntian could enhance the overall understanding of the universe. Collaborative efforts could enable a multifaceted approach to solving cosmological mysteries, creating a comprehensive picture that individual telescopes may not achieve alone. This synergy could lead to groundbreaking discoveries that redefine our understanding of the cosmos. Conclusion: the Xuntian Space Telescope is not just another addition to the roster of space observatories, it represents a transformative approach to astronomical research. Its in-orbit maintenance capability, wide field of view, strategic geopolitical context, focus on dark matter and energy, and potential for collaborative synergy are all critical elements that could significantly influence the future of astrophysics and space exploration. As scientists prepare for its launch, these often overlooked details could lead to new paradigms in our understanding of the universe, emphasizing the importance of keeping an eye on the broader implications of technological advancements in space science. 1. Advanced imaging technology and scientific objectives. The Xuntian Space Telescope is designed with cutting-edge optical technology that enables it to have a field of view 300 times greater than the Hubble Space Telescope. With a 2-meter primary mirror, the telescope is poised to conduct extensive surveys over a decade-long operational period, facilitating groundbreaking research in areas such as dark matter and dark energy. Its primary scientific objectives include measuring weak gravitational lensing, mapping the cosmic web, and studying galaxy formation and evolution. This focus on fundamental cosmological questions underscores the telescope's potential to significantly advance our understanding of the universe. 2. In-orbit maintenance and upgradability. One of the unique features of the Xuntian is its ability to undergo maintenance and upgrades while in orbit, thanks to its shared operational framework with the Tiangong space station. This capability differentiates it from other space telescopes such as the James Webb Space Telescope, which is located too far from Earth for repairs. The potential for continuous upgrades means that the Xuntian can incorporate the latest advancements in imaging technology throughout its operational life, extending its usefulness and enhancing scientific returns over time. 3. Strategic timing and competitive landscape. The Xuntian's planned launch in late 2026 places it in a competitive landscape with other significant projects, notably NASA's Nancy Grace Roman Space Telescope, which is scheduled for 2027. This timing highlights the growing capabilities of China's space exploration efforts and the strategic importance of the Xuntian in enhancing China's position in global astronomy. The competitive environment may foster collaborative opportunities among different space agencies even as geopolitical tensions exist,
providing a platform for shared scientific discovery and innovation.
4. Global implications for astrophysics and space exploration. The development of the Xuntian telescope signifies a notable advancement in China's contributions to global astrophysics and space exploration. By aiming to provide critical insights into the nature of dark matter and energy, the telescope could reshape our understanding of fundamental physical laws and cosmological phenomena. Additionally, the advancements in technology and operational strategies demonstrated by the Xuntian may inspire future international collaborations and innovations in space observation, fostering a more integrated approach to exploring the universe and addressing shared scientific challenges. 1. The Hubble Space Telescope 1990. Launched in 1990, the Hubble Space Telescope revolutionized our understanding of the universe by providing unprecedented images and data. Its ability to observe deep space with clarity has led to significant discoveries,
including the rate of expansion of the universe and the existence of exoplanets.
The Hubble has been serviced multiple times by astronauts, allowing for upgrades and repairs that have extended its operational life well beyond initial expectations. 2. The Kepler Space Telescope 2009. Launched in 2009, the Kepler Space Telescope was designed specifically to survey a portion of the Milky Way galaxy to discover Earth-like planets orbiting other stars. Its mission was highly successful, leading to the discovery of thousands of exoplanets and significantly advancing our understanding of planetary systems. Although Kepler was not designed for servicing, the data it collected continues to be analyzed and has laid the groundwork for future missions aimed at understanding planetary habitability. 3. The James Webb Space Telescope 2021. Launched in December 2021, the James Webb Space Telescope is the most powerful space telescope ever built,
designed to observe the universe in infrared wavelengths.
It aims to study the formation of stars and galaxies, the atmospheres of exoplanets, and many other cosmic phenomena. Unlike Hubble, JWST is positioned at a stable point 1.5 million kilometers from Earth, which makes it impossible to service. Its advanced technology and large mirror provide a significant leap in observational capabilities, complementing the existing fleet of telescopes.
Future outlook. Predictions for China's Xuntian Space Telescope deployment in 2026. Introduction.
As China prepares to launch the Xuntian Space Telescope, also known as the China Space Station Telescope CSST, in late 2026, the scientific community is poised to witness a transformative period in the field of astronomy. With a budget of approximately $150 million dedicated to advanced imaging technology, Xuntian is anticipated to make significant contributions to our understanding of dark matter, dark energy,
and galaxy evolution. This analysis will outline key predictions concerning the telescope's deployment and its implications for future astronomical research. Phase 1. Successful launch and initial operations, late 2026. The Xuntian is scheduled for launch on December 21, 2026.
Given the complexities involved in space missions, there is a strong likelihood that the launch may encounter delays. However, the Chinese Space Agency has a track record of overcoming technical hurdles.
Upon reaching its operational orbit, initial phases will focus on system checks and calibration of the telescope's advanced optics and instruments.
This period is critical for ensuring that the telescope can achieve its promised capabilities,
setting the stage for its ambitious decade-long mission. Phase 2. In-orbit upgrades and maintenance, 2027 to 2036.
One of Xuntian's most significant advantages is its ability to be serviced in orbit due to its proximity to the Tiangong space station. Predictions indicate that periodic upgrades will enhance the telescope's capabilities over its operational period. This feature could lead to improvements in imaging technology and data processing, allowing Xuntian to remain at the forefront of astronomical research even as new technologies emerge. The ability to adapt to advancements in optics and sensors could potentially extend its operational lifespan beyond the initial 10 years, making it a long-term player in the field. Phase 3, Collaborative Research and Global Impact 2030 onwards. As Xuntian begins to deliver data, it is expected to foster collaboration among global astronomical communities by complementing missions of other telescopes, such as NASA's Nancy Grace Roman Space Telescope and ESA's Euclid. Xuntian will provide a comprehensive view of the universe. Predictions suggest that joint observational campaigns will lead to breakthroughs in understanding dark matter and dark energy. The wealth of data generated will not only enhance theoretical models but also spur new hypotheses that drive further research. Phase 4, Pioneering Discoveries in Cosmology 2031 to 2036. The primary scientific goals of Xuntian include mapping dark matter through weak gravitational lensing and studying cosmic voids and galaxy clusters. It is predicted that within a few years of operation, Xuntian will yield significant insights into the distribution of dark matter and its implications for galaxy formation and evolution. Furthermore, the telescope's unique capabilities may lead to the discovery of previously undetected cosmic phenomena, offering new perspectives on the nature of the universe. Phase 5, Influence on Space Policy and International Relations 2035 onwards. The advancement of the Xuntian Space Telescope is likely to have broader implications beyond scientific research. With increasing capabilities in space observation, China is expected to enhance its position as a global leader in space exploration. This may lead to shifts in international space policy, with potential collaborations and partnerships emerging in the field of cosmology. As nations recognize the importance of astronomical research for understanding fundamental questions about the universe, diplomatic efforts may increase to foster cooperation in space exploration despite existing geopolitical tensions. Conclusion. The Xuntian Space Telescope represents a paradigm shift in astronomical research and a significant step forward for China's space program. With its advanced technology in orbit, upgrade capabilities, and strategic positioning alongside the Tiangong space station, the telescope is set to deliver groundbreaking insights into the cosmos. As it embarks on its mission, the astronomical community can anticipate a future rich with discoveries, collaborations, and an enhanced understanding of the universe's mysteries. The next decade will be pivotal for both Xuntian and the global scientific community, shaping the future of astrophysics and our understanding of the fundamental forces that govern the universe.